Okay, so the big ideas for topic 3. Be on the lookout for these as we go. What is habitat fragmentation versus habitat destruction? So, what are those two things? What is an invasive species? And why do invasive species cause harm to ecosystems? Okay, so today we're going to look at some human impact on ecosystems. When I say some, I really mean some. Like, I mean a couple, okay? In fact, mostly we're going to look at one. Remember, human impacts on ecosystems, you can and people do their entire degree and then devote their entire life to studying these, right? Everything we do has an impact on the ecosystem. Again, we are not separate from ecosystems. We are part of ecosystems, right? We sometimes can forget that. So everything we do in some way or another will have some impact on some ecosystem. So what we've looked at is matter cycling and energy flow, right? So to impact an ecosystem, you impact those two things. Whether it's making a species go extinct, that's going to impact energy flow, right? You've removed something from the food chain. But it's also going to impact matter cycling, right? If that's a producer, it can no longer absorb nitrates from the ground. That affects the nitrogen cycle or whatever it is, right? It's going to impact those two things. So as a result of our disruptions, many species are now facing extinction, okay? The current rate of extinction we're going through is about 1,000 times greater than what we call the background extinction rate, okay? Which is just the rate at which species go extinct, even if nothing's happening. We're about 1,000 times past that. So we are officially in a mass extinction. Those happen in things like ice ages or back when the dinosaurs were hit by a meteorite, right? That is a mass extinction. We are currently in one of those. And the reason is us. It's actually estimated that the current rate of extinction is actually 100 times greater than was seen during past mass extinctions. So, not just the background extinction, past mass extinctions. So, such as the one that wiped out the dinosaurs. Species are going extinct at a 100 times faster rate than they were when the dinosaurs were going extinct from the asteroid. Take a second to think about that. We have had an incredible impact on this planet. We do a lot of good, okay, but we definitely could do a bit of cleaning up our act a bit, right? I would say, wouldn't you agree? Literally dozens of species go extinct every day. So by this time tomorrow, there will be dozens of species that will not exist anymore that exist right now. Pretty sobering thought. Okay, so in other words, not only are we causing a mass extinction, we are doing it faster than anything else, including an asteroid, ever has, as far as we can tell. Okay, so two kind of quick definitions we're going to get out of the way here. Okay, are habitat fragmentation and habitat destruction. So they're related, but they're different. So habitat fragmentation is when you convert a formerly continuous habitat into patches, which are separated by non-habitat areas. So probably the simplest example, though there's lots I can think of, is like something like building a highway through a park, through like a national park or something, right? And at first you might be saying, I mean, it's not too bad, right? It's just one little strip of road. How big is a road? It's not that big. We're not taking up that much habitat. But we have to be careful. If the area was formerly continuous, that means that habitat has developed that way, right? So maybe over here, on this side of the habitat is where there's a nice river, a nice water source, and lots of fish. So predators that eat fish can come and eat there. And herbivores know that there are these nice water loving plants that like to grow on the banks of the rivers. So there's a nice ecosystem going on over here. And they've always kind of lived in this habitat where you could just roam. But suddenly there's a highway in the middle. And so now, if you're an organism that lives over here, it's not as easy for you to get over there. In fact, they often will even barricade the highway so that they don't get roadkill, right? So it might not seem that bad. Okay, we've only taken this tiny little slice of the ecosystem, but we have to be careful. Splitting up an ecosystem, just saying, oh, I only took this little amount isn't always true, right? Now you've separated this part of the ecosystem from this vital water source, this vital place where stuff was growing. So it's not as simple as just, oh, well, we only took a little bit. Same as building a dam, right? When you build a dam, you cut one part of a river off from the next part of the river. You might think, well, overall, the dam's not that big, but you're doing habitat fragmentation. You're taking one continuous habitat and splitting it up into parts that those organisms are not used to, that ecosystem did not develop to support. Okay, and then there's habitat destruction, and this is when you permanently actually do destroy an organism's habitat for real. Okay, so this is like clearing out forest and putting up a parkade or something, right? You will That ecosystem is not just split up, it has actually been destroyed. And obviously, that one could be even more devastating, right? Okay, so just to get some context on the kind of levels of risk that we can use to measure the threat that wildlife is under, we use these terms. So let's just go through, kind of define them, and then I'll give you an example from Alberta. You might get a little bit sad when you realize how many of them are just caused by human activity. So the first one, the lowest level of risk is vulnerable. What does vulnerable mean? It means that the species is likely to become threatened or endangered soon, which doesn't mean much until you know what those mean, but just hang tight. An Albertan example of a vulnerable species is the wolverine. Okay, habitat fragmentation is the issue for wolverines. They clear cutting in the forest has caused what used to be a continuous area for them to roam. Well, it's now split up because of clear cutting in forests, so they don't have a continuous forest to hunt and to roam in and to that they're used to, right? And so that has caused serious issues in their ability to find the resources they need to survive. Okay, just going to switch to black so it doesn't become one big blue blob. Threatened, what does that mean? It means the species is likely to become endangered if we don't do something now, if the factors that caused it to be vulnerable are not reversed. So, in other words, vulnerable, if we don't make things worse, they might recover. Threatened is that's not good enough. You have to actually take actions to undo things, or it's not going to get better. What's an example of that from Alberta? The peregrine falcon. Okay. They are actually a victim of DDT. You might have learned this in younger biology classes. DDT was a chemical that we used to kill mosquitoes, but we didn't think about food webs when we did it, and the fact that peregrine falcons were apex predators at the top of the food chain. So a little bit of DDT will kill some mosquitoes, but as we know from energy pyramids, right, a smaller fish might eat 1,000 mosquito larvae, and then a bird might eat 100 fish, and then an eagle might eat 50 of those smaller birds. By the time it gets up to the falcon, they're getting a big dose of DDT, and what it caused was for their eggshells to not harden, and this really impacted their populations. And so now in Alberta, they are threatened. There is also a low availability of quality habitat. That's habitat destruction for you. All right, what does endangered means? It means it is on the verge of extinction, okay, or extirpation throughout their range in Alberta. Again, you don't know what those means. These are getting worse as we go, okay? So if we do nothing to save them, they will soon be gone. There are several examples in Alberta. There's many examples. I got several here just off the top, okay? Woodland caribou, the swift fox, the burrowing owl. Both the swift fox and the burrowing owl, they've experienced a loss in habitat, so there's that habitat destruction again, as native prairie grasslands have been converted to farmland, right? So they've lost habitat. Their usual grassland habitat where they can hunt is no longer a grassland, it's a field, it's a farmer's field. Grasslands were converted to farmland, taking away their habitat. All right, extirpated. What does that mean? That means it is extinct in an area. It's not extinct in the world, but it's extinct somewhere. So for us, we're saying it's extirpated from Alberta, means they used to live in Alberta, but we have actually destroyed that population completely. So an example of a species that has been extirpated from Alberta, the black-footed ferret. Okay, so these used to be all over Alberta. Now they depended heavily on something called a black-tailed prairie dog. But the black-tailed prairie dog, this is kind of related to the example with the burrowing owl, they used to make their burrows in the grassland. That has now been converted to farmland, right? In fact, that's actually the burrowing owl used to use the prairie dog's abandoned homes to make its home. So since the black-footed ferret depended on the black-tailed prairie dog for food, and the black-tailed prairie dog their habitat has been destroyed a lot. Well, they're out of luck too now. So they're actually extinct in Alberta. They don't exist in Alberta anymore. However, they can still be found in the US, so they're not fully extinct. They're just extirpated from Alberta. Once again, farmland conversion, okay? Now extinct, sure we know what that means. That means it's gone. That species is gone. It's never coming back. It is lost, no longer exists anywhere in the world. So what's an example of a species from Alberta that has gone completely extinct? There's something called the Banff long-nosed dace. Okay, what is that? It's a fish. And this fish actually only kind of had one very specific habitat. Its habitat was in this one bog that was fed by hot springs in Banff. It thrived there, but then Banff became a little more touristy. They got pools put in, right? And leaching happened. Again, a connection to the water cycle, right? Leaching happened. Chemicals from chlorine pools got into this habitat, this ecosystem. The habitat was destroyed. It was permanently altered. And so these fish could not live in a chlorine heavy pool, obviously, right? So they are now extinct. Okay, so habitat destruction and habitat fragmentation, obviously two ways that humans can really have a negative impact on ecosystems. There's another one here too. We're kind of gonna shift focus here to a different way that humans can have a big impact. It's not always humans, but again, 99% of the time humans do this because they're the ones of making these kinds of things happen because of our ability to move all over the world. Okay, so again, as we've seen, ecosystems exist in a delicate balance, right? All species play an important role in supporting the ecosystem. This balance is possible because all species in an ecosystem have evolved together, right? The longer you're kind of living in the same space, the more you kind of find your role. The longer you work at a job, the more you kind of know how you fit in and what your strengths and your weaknesses are. It's the same in an ecosystem, but they all have to kind of be there from the beginning while the ecosystem is working out what that balance is, right? They each develop a particular niche within the ecosystem. Now, here's that word again, the limiting factors. Those are the things that limit a population from getting too out of control, right? They exist there to kind of prevent one organism from getting too much of an upper hand. And there's a nice balance over thousands of years of coevolution that is in place in most ecosystems. So things like natural predators, right? Diseases, right? Remember when we saw the cordyceps, the fungus that turned ants into zombies, it said this is an essential part of an ecosystem because without that, those ants could get too much of an upper hand. So nature kind of said, nope, careful ants, don't get too cocky, right? Here's a zombie fungus. Okay, things like temperatures, water availability, all of those are limiting factors. Ensure that no one species gets too much of an upper hand, throwing the ecosystem out of balance or even causing it to collapse. So just to get you thinking about this here, okay, about how the ecosystem is in such a perfect balance, it says wolves hunt deer who graze on shrubs. I want you to try answering these on your own, okay? Pause the video, and then you can come back and see how my answers compare to yours, okay? But wolves hunt deer who graze on the shrubs. So without the wolves, what could happen to the shrub population? Well, this is an example of a balance, right? If there were no wolves, the deer would just be free to multiply and multiply and multiply, and they would eat up all the shrubs, right? They would just go to town. There's no one hunting them. Happy days. But eventually, what would happen to the shrubs? Well, they would run out, right? And then what happens to the deer? They're going to starve, and the whole ecosystem starts to collapse. See what I mean? There's this balance in place here. So without the wolves, what would happen to the shrub population? Right? If the deers don't have predators, they're just going to keep eating shrubs and keep having babies until there's no more shrubs left. And if there's no more shrubs left, those are a producer. Those are at the bottom of the food chain. So if you lose those, your ecosystem is in trouble. So you see what I mean? The wolves being there is important for the balance of the ecosystem. They eat some deer, so they keep that population at a reasonable level so that the shrub population can stay at a reasonable level, right? As much as the deers might not like it, getting eaten is actually good for them in the long run because they don't destroy their food source. Okay, wolves are an apex predator, which means they're the top of their food chain. What keeps the wolf population in check? You have to think back a bit on this one. What stops the wolves from going out of crazy? Because nothing eats them. So do you remember the three types of interactions we talked about? The three types of biotic interactions? One was predator-prey, right? So if the wolf population gets too big and they start eating deer like crazy, well, they're going to start getting hungry. There's not going to be enough deer to go around anymore. And so what will happen to their population? It'll have to drop again, right? There's not enough resources to support a big population. So that's what keeps the wolf population in check. See this nice kind of perfect balance that we have going on here? And that is because this ecosystem has developed that way over many years, right? Everyone has kind of grown into their role. Now, what happens when you take a species that did not develop in that ecosystem and drop it in suddenly? Well, the limiting factors that apply to everything else in that ecosystem don't apply to it necessarily. So it can outcompete the other organisms and throw off the entire balance. It's not that the organisms themselves are bad, it's just that where they are is bad because they didn't evolve there. They're not part of that ecosystem. They don't fit into the delicate balance that's been cultivated over many years. And we call these invasive species because they are invasive to some ecosystem. They don't belong there. They didn't evolve there. Okay, I'm going to show you two videos. Fair warning, if you are kind of an insectophobe, you might not like these. It's some close-up shots of a lot of insects, okay? But I'm going to show you two. The first one is going to show you the balance that nature can kind of have here. This is giant hornets in their usual ecosystem in Japan. So you may have actually heard that some of these were found in America this year. They are an invasive species, but not in Japan. That's where they evolved, okay? And they co-evolved with honeybees. So Japanese honeybees have a defense against these guys. There's a balance to keep these giant hornets from getting too much of an upper hand. There's a strategy that the European honeybees develop to cope with them.
Within nature's intricate web of checks and balances, there is a place for payback. These too are honeybees. They made their hive in a hollow tree. They too are caring for their young. But these are native Japanese honeybees, and they're not quite as defenseless as their European cousins. They have evolved a secret weapon against the giant hornet. One they may need often in this deadly season. This hornet is the advanced guard of an attack force the bees could never withstand. But this time, the bees set a trap. They want the hornet inside. And the hornet obliges. The scout's main task is to mark the hive with the telltale pheromone so that her sisters can find it later. But the native honeybees know her game. By swinging their abdomens to and fro, they signal their strategy to one another. The bees hold off until the last possible moment. And then, as if of one mind, they swarm. The hornet is engulfed by hundreds of bees. But they don't sting the intruder. Instead, as revealed by thermal photography, they all begin to vibrate, gradually raising their collective temperature to 117 degrees Fahrenheit. Japanese honeybees can tolerate a temperature of 118 degrees. Their victim's upper limit is 115. The hornet scout is slowly roasted alive. And the secret of the honeybee's location dies with her.
So, because they co-evolved in the same ecosystem, Japanese honeybees worked out a way to deal with the hornets. Did you catch what it was? Yeah, they get on it and they start vibrating, and that raises their body temperature enough to actually cook the hornet alive. Pretty metal, okay? Great, okay, Japanese honeybees, they've dealt with these things for thousands of years. So together, the two species have worked out a way to keep each other in check so that one doesn't get too much of an upper hand, right? However, what would happen if we were to take these giant hornets and bring them somewhere where they did not co-evolve in that ecosystem? And so different organisms have no idea. They never learned this. They never evolved this defense. Well, I got to warn you, it's kind of sad. Okay, if you watch this video, you'll feel really bad for the bees. But it really does illustrate the fact that if species do not evolve together, they don't necessarily develop the appropriate mechanisms for dealing with one another, and that balance gets thrown off. I'll show you this one.
The The bees rush out in defense, but this is their undoing. One by one, they're picked off. More hornets join the attack. The hornets emit a chemical rallying cry, and this triggers a unique phenomenon. They no longer carry bee carcasses back to the nest. Instead, they slaughter, then cast aside the body of every defender they meet. It's the start of a mass attack. Each warrior can kill up to 40 bees a minute. The European bees outnumber the hornets 1,000 to 1, but they didn't evolve alongside these huge Asian predators and have no effective defense. Within the hour, 10,000 bees are down. Their stings are not strong enough. 30,000 honeybees have died in 3 hours, falling victim to just 30 giant hornets. By midday, the defenses are breached. Real plunder begins. The hornets pay little attention to the few surviving bees. The motivation for the attack lies within the combs. Inside, the defenseless young are butchered. The succulent and nutritious flesh will be a massive boost to the hornet's own larvae and their queen's fortunes.
Okay, instead of going through these examples with you, I'm just going to show you a video that actually goes through 3 examples of invasive species and does a really good job of explaining why they have such a bad effect on the ecosystem that they have invaded. Okay, I will still fill this out so you can go check the notes if you are curious about these. I wouldn't recommend you do because these are actually Canadian invasive species, so these are ones that are pretty relevant to us. Okay, but I'll show you the video now and you can read about these after. Before the video, though, the last thing I just want to mention, when you come back to look at these ones that I'm going to write in the notes here, you'll notice the way that they always end up in the ecosystem that they're invading is pretty much always humans, right? Because we are the only really species that travels all over the world. So a lot of the time we don't even mean to, we just accidentally bring them. In fact, the giant hornet that you just saw, those ended up in Vancouver because they got stuck in some shipping crates that came from Japan. So we just have to be careful about how we're doing this stuff. And then sometimes it's not even an accident. Like one of the ones you'll see in the video is someone just let a bunch of rabbits go.
Massive vines that blanket the southern United States, climbing as high as 100 feet as they uproot trees and swallow buildings. A ravenous snake that is capable of devouring an alligator. Rabbit populations that eat themselves into starvation. These aren't horror movie concepts, they're real stories. But how could such situations exist in nature? All 3 are examples of invasive species, organisms harmful not because of what they are, but where they happen to be. The kudzu vine, for example, had grown quietly in its native East Asia, eaten by various insects and dying off during the cold winters. But its fortunes changed when it was imported into the southeastern United States for porch decoration and cattle feed. Its planting was even subsidized by the government to fight soil erosion. With sunny fields, a mild climate, and no natural predators in its new home, the vine grew uncontrollably until it became known as the plant that ate the South. Meanwhile, in Florida's Everglades, Burmese pythons, thought to have been released by pet owners, are the cause of decreasing populations of organisms. They're successfully outcompeting top predators, such as the alligator and panther, causing a significant reduction in their food sources. They're not a problem in their native Asia because diseases, parasites, and predators help to control their population size. And in Australia, European rabbits eat so many plants that they wipe out the food supply for themselves and other herbivores. They're a pretty recent addition, intentionally introduced to the continent because one man enjoyed hunting them. Like the Burmese pythons, various factors in their native habitat keep their numbers in control. But in Australia, the lack of predators and a climate perfect for year-long reproduction allows their populations to skyrocket. So why does this keep happening? Most of the world's ecosystems are the result of millennia of co-evolution by organisms, adapting to their environment and each other until a stable balance is reached. Healthy ecosystems maintain this balance via limiting factors, environmental conditions that restrict the size or range of a species. These include things like natural geography and climate, food availability, and the presence or absence of predators. For example, plant growth depends on levels of sunlight and soil nutrients. The amount of edible plants affects the population of herbivores, which in turn impacts the carnivores that feed on them. And a healthy predator population keeps the herbivores from becoming too numerous and devouring all the plants. But even minor changes in one factor can upset this balance, and the sudden introduction of non-native organisms can be a pretty major change. A species that has evolved in a separate habitat will be susceptible to different limiting factors, different predators, different energy sources, and different climates. If the new habitat's limiting factors fail to restrict the species' growth, it will continue to multiply, outcompeting native organisms for resources and disrupting the entire ecosystem. Species are sometimes introduced into new habitats through natural factors like storms, ocean currents, or climate shifts. The majority of invasive species, though, are introduced by humans. Often this happens unintentionally, as when the zebra mussel was accidentally brought to Lake Erie by cargo ships. But as people migrate around the world, we have also deliberately brought our plants and animals along, rarely considering the consequences. But now that we're learning more about the effects of invasive species on ecosystems, many governments closely monitor the transport of plants and animals and ban the imports of certain organisms. But could the species with the most drastic environmental impact be a group of primates who emerged from Africa to cover most of the world? Are we an invasive species?
Okay, that wraps up topic 3. So what is habitat fragmentation? What is habitat destruction? And also just be able to explain the difference between those two things because they're similar, but they are not the same thing. Okay, what is an invasive species? And why do invasive species cause harm to ecosystems? So what is it about them that makes them so dangerous for an ecosystem? Okay, if you're looking for practical stuff, try out the topic 3 section of the practice assignment on the Google Classroom or in the agenda.